So today we're going through Unit 2, Lesson 2. We're going to talk about mutually exclusive and non-mutually exclusive events. This one ties in closely to what we did in Lesson 1. So first let's look at the difference between the two. So experiment 1, we're grabbing a single card from a deck of 52 playing cards. We want to know what is the probability of choosing a 5 or a king. If you think about it, when you reach in and pull out a card, it's either going to be a 5 or a king. This is an example of mutually exclusive events. But what if I asked you the next question? So experiment 2, we're again grabbing a card from a deck of cards, 52 cards. What is the probability of choosing a club or a king? So in this case, when I grab my card, it could be a club, it could be a king, but it's actually possible that the card could be a club and a king at the same time. So you have to be a little bit careful whenever I'm using the word or in a question. You have to be careful and think, can it be both events at the exact same time? Because if it can, we have to be a little bit different with our probability. This is an example of non-mutually exclusive events. They're related to each other. You can have both occur at the exact same time. So I'm going to skip the next page. That's practice just identifying if it's non-mutually exclusive or mutually exclusive. So you can look at your notes for that one. Let's go on to the following page and have a look at this one. I want to know from a standard deck of 52 cards, what's the probability of getting an ace or a queen? So remember that symbol from set theory, that right side up U means or. So what you're going to do is first of all figure out probability of an ace. There's 4 out of 52 cards are aces. Or means plus, so when I'm saying in my head or, I'm going to add my probabilities together. A queen, there's 4 in the deck. And then before you finish the question, whenever we're using the word or, you have to think carefully. Can I have a card that's an ace and a queen at the same time? In this case, no, I can't. So I'm done the question. I can just add these together and then simplify. But if we look at the next one, I want the probability of an ace or a club. So probability of an ace, that's going to be 4 out of 52 cards. Or means plus. Probability of a club, there's 13 clubs in a deck of cards. And then I'm going to think carefully, can I have a card that's an ace and a club at the same time? Yes, an ace of clubs. There's one situation where I can have both of those occurring at the same time. If you have that, you have to minus it off because you've ended up counting it twice. You've counted it in your aces as well as in your clubs. So you've counted it one too many times, and you're going to have to minus it off. And then you're going to simplify your fraction. Let's try the next one. We want probability of a face card or a black card. Face cards are Jack, Queen, Kings. There's 12 in a deck. I want my probability of a black card, that's half the deck, 26 out of 52. And then I'm going to think carefully, can I have face cards that are black cards? Yes, there's going to be 6 different face cards that are also black cards. So you're going to have to minus off those possibilities. And then you're going to get 32 out of 52, and then you're going to simplify it. So the biggest thing is just remembering with the or, always ask yourself at the end, can I have both at the same time? If you can, you have to minus them off. So you can look at the rest of the examples for that one. I'm just going to now tie this into Venn diagrams really quickly. So I'm going to kind of skip this page. Actually, I'll do the top part here. Imagine we're drawing a card from a deck, and we're letting event A be that a heart is drawn, and B is that a spade is drawn. If you think about that, hearts and spades, you can't ever have them at the same time. So if I was actually to write out all my possibilities in a Venn diagram, again related to Unit 1, you'd see that your Venn diagrams don't touch at all. This means they're mutually exclusive and they don't share, you can't have both at the same time. And in Venn diagrams, remember from our first unit, if we were to draw it, they'll look like disjoint sets because they don't have anything that can be both at the same to the next section here. I'm going to do the bottom one first, and then one more, and then that'll be it for this one. So we can use Venn diagrams to organize our information for probability as well. So here, a car manufacturer keeps a database of all the cars available for sale in Western Canada. For Model A, it says they have 43% have heated seats, 36% have a sunroof, and 49% have neither. So we can organize this in a Venn diagram just like in Unit 1. We have cars with heated seats. We have cars with sunroofs. It says 43% have heated seats. Remember, that means the total for this entire circle is 43%. 36% for sunroofs, and then 49% don't have either, so they're going to be floating around the outside. If you're dealing with percentages, you can assume that your universal set should be at 100%. So a little refresher from this now, if we want to find out our values, we're missing these 3 values, we can work with our information to figure it out. I know everything added together should equal my universal set of 100%. So if I go 100% and I minus off the 49% portion, the outside portion, and I minus off this whole circle of sunroofs, I only have one spot left. So that spot must be 15%. Okay, once you have that one, the rest fall like dominoes. I know this entire circle has to equal 43, so I'm going to go 43 minus 15 to get the middle. Now I know my sunroof circle has to add to 36, so I'm going to go 36 minus 28 to get that. Now my Venn diagram is complete. Then the question asks, determine the probability that they have both heated seats and a sunroof. Heated seats and a sunroof, and I want to know that probability. We remember from our Unit 1 for and that it means the overlap section of your Venn diagram, so I can see that there's a 28% chance that that car is going to have both. We can do a probability like this with percentages in Venn diagrams, and we can do it with regular numbers, so I want to do the one on the next page as well to show you how that works. So, a survey of 64 people. That means your universal set is 64 people. It says 45 believe that Elvis is still alive. So in my Elvis bubble, it's going to be 45. 49 believe they've been abducted by aliens. So that whole circle should add to 49. Then it says 42 believe both of these things. So that's going to go in the middle. And again, we're going to fill in all our missing information. So the Elvis circle should add to 45, so I know this has to be 3. And my alien circle has to add to 49, so that must be 7. And then don't forget, you might have a number dangling around the outside. So if I go 64 and I minus all of those, I can see there's still 12 left over hanging around the outside. Now that we have this, we can figure out probability. Questions below. So it says, determine the probability of believing neither of the things. So not believing in anything. I don't believe in Elvis, and I don't believe in the aliens. So I can see in that category, not Elvis, not aliens, the answer is 12, but I want probability, so I'm going to write it as 12 out of the total of 64 people. And then you can simplify and write it that way. So that's a slight difference between percentages and with the actual numbers. And you can check out the rest on your Google Notes, and always come ask me if you have any questions at all. Have a great day.